Hello, in this video we are going to look at changing order of integration. So a double integral has an order of integration. Let's look at an example. So suppose we have double integral. The outer bounds are 0 to 1. Inner bounds are labeled 0 to x. We have some function. And then we have dy dx. So the order of integration is defined by this dy dx. All right, so this says to integrate with respect to y and then to integrate with respect to x. And you can use that order of integration to go through and label the bounds here. So since we have dy first and we're integrating with respect to y first, that means that these first set of bounds, the inner bounds, are in terms of y, are y functions. So we have y equals 0 to y equals x. And then since dx is second, that means the outer bounds are x bounds. So what you can do is you can go through and use the order of integration and combine with the bounds to define the region of integration. So the region of integration is defined by the bounds. Okay, and so if you do as I just did, right, you can use the order of integration to label the bounds. And then once you have the bounds labeled like this will define the region that you're integrating across. So the y bounds are the top and bottom. And the x bounds are the right and left. So in this case, we have the top of the object is defined by y equals x and the bottom by y equals 0. And then the left is at x equals 0 and the right is at x equals 1. So once you've got that information, you can go through and use that information to sketch the object. All right, so let's go ahead and do that. Okay, so let's just take a look. What do we have? So we have the top is y equals x. So we want to go ahead and graph y equals x. The bottom is y equals 0. So y equals 0 is the x-axis. So we want to go ahead and Draw a line on top of the x-axis. Okay. And then the left is at x equals 0. And so we can just put a little mark there. So we want to start on the left at x equals 0. And then the right is given by x equals 1. So if we go through and draw a line for x equals 1, we get x equals 1. And so that's our region of integration. All right, so to change the order of integration, what we need to do is we need to go through and reverse the dy dx, right? So let's just write this down. So to change the order of integration, we have to reverse the dy dx and create new bounds using your sketch. Okay, so if we go back to our original was dy dx. So we're going to change the order of integration to dx dy. So we're reversing the order. Once you've done that, now we need x equals and x equals. So now we're going from, so one thing to keep track of and memorize is that x bounds left and right, y bounds top and bottom. All right, so since we're doing x bounds first here, we're doing left to right, bottom to top, or right to left, top to bottom, however you want to memorize it. And so the original went bottom to top, left to right. The new one's going to go left to right, bottom to top. So we're reversing the order. Okay. So now we need to look at our sketch and figure out, all right, so the left is defined by x equals what? All right, so one of the things that can be helpful with this is to go through and label your sketch, which I did not do. So this is the line y equals x. And then here we have x equals 1. Right. And then I guess you could put this as well. This is y equals 0. All right. And then we can go, well, frequently you'll end up using those. Frequently. Well, you're always going to end up using those. All right. So now we want the left. So the left side of our object, if you just look at the object, the left side is going to be this line here, right? That line is y equals x. But if we wanted to define it as x equals, then we could just reverse it around. So instead of thinking of it as y equals x, it's x equals y. All right, and then the right side of the object, so if we look over on the right side is defined by this line. That is at x equals 1. And then the bottom, right, the bottom is here at y equals 0. And then the top is not defined. So this can happen where you've got to go through and figure out what the top value would be. And so the way that you can go through and do that is you can use the given information. So what is this? What is the location of the top here in terms of y? It's at that point where this line and this line intersect. Well, if you've got the two lines, well, to go through and find where two lines intersect, you can go through and substitute. So if you take the x equals 1, plug it into y equals x, you'll get y equals 1. All right, and that's the new integral, right? So I didn't set this one up so that we could go through and integrate it, because the point of the video is just on the changing order of integration. But if you had whatever function you have here, you would just go through and integrate with respect to x and then integrate with respect to y, and you should get the same results as you would have gotten in the original, right? So changing the order of integration does not change the value of the integral, it just changes how you go through and perform the integration. Why would you change an order of integration? It might be that a different order of integration would make the integral easier to evaluate. So you could have an initial order that's very difficult to go through. You have a function that's very difficult to integrate with respect to y and then with respect to x, but would be easy in the reverse order. And so that would be a reason why you'd want to reverse the order of integration, is to get to an easier integral. Let's go through and do a few more examples. So let's suppose we had 0 to 2, y squared to 4, f of x comma y dx dy. Okay, so the first thing that you want to do is you want to go through and use the order of integration that's given to label the bounds. All right, so since we have dx first, that tells us that this is x equals and x equals. And then dy second, we have y equals and y equals. All right, and the way that you interpret this is that the x bounds are left and right, the y bounds are top and bottom. So what we have is we have the left is x equals y squared. The right is x equals 4. The top is y equals 2. I keep changing the order around. It should go left, right, bottom, top. Sorry about that. And then the bottom is y equals 0. All right, so what we want to do is once you've got all that, you want to go through and draw a picture. All right, so we have x equals y squared. So if you don't remember how to graph x equals y squared, you think about y equals x squared. You just kind of reverse the variables to something you're more familiar with. So y equals x squared looks like this. And then what you want to do is you want to just take that same picture, and everything that you do up, you want to do to the right instead of doing up. Same idea. It's the same. It's effectively, well, it is the same thing as going through and reflecting across the line y equals x. Just think about this picture, but you're doing it to the right. And so we'll get that graph. All right, so that's x equals y squared. And then we have x equals 4. All right, and then so that's the left and right of our object. And then the top is at y equals 2. And then the bottom is at y equals 0. Oh, hold on. So it's cutting off the bottom half of this. All right, so maybe we should have used some red in here. All right, so we have it's cut off here at y equals 0. And so we can just kind of go through and maybe color in the object. And so it's not the bottom part, it's just the top part. All right, and we can just label that. We got y equals 0. All right, so we got y equals 0. We got x equals y squared. And we've got x equals 4. So that's our object. All right, so to go through and change the order, let's change back to black. To change the order, so we originally had dx dy, so we're going to want dy dx. And then we'll have y equals x equals x equals. All right, so what we want now is we want the bottom of the object and the top of the object. So the bottom of the object, if we look at our picture, the bottom of the object is defined by y equals 0. The top of the object is defined by this curve here. All right, so that is going to be, that comes from x equals y squared. So x equals y squared, we could go through and solve for y by taking the root of both sides. Now, technically, there should be a plus or minus there, but we only want the top half, so we can just discard the negative root. So we're going to get y equals root x. So that's the top of the object, is y equals root x. All right, and then if you look at your picture, so in terms of x, we start on the left at x equals 0. And we stop on the right at x equals 4. And that's your new order of integration. Let's try one more. Okay, so the first thing that you want to do is use the given order of integration to label your bounds. So we have dx first. That means that these are x bounds. So we go from x equals y plus 1 to x equals 3. And then y seconds, that means these are y bounds. So the x bounds define the left and right. So we have the left is defined by y, not y, by x, defined by x equals y plus 1. The right is defined by x equals 3. The bottom is y equals 0. And top, y equals 2. All right, so to define, we need to graph it first. Hold on. Getting ahead of myself there. All right, so draw a coordinate axis. All right, so first we have the left of the object is x equals y plus 1. So we want to go through and graph x equals y plus 1. So we don't, I mean, typically when we have graphs where we have just x to the first and y to the first like this, we know that's a line. We go through and we put them into mx plus b form. So let's do that. So to do that, we would swing the 1 over to the other side. And so we could rewrite this as y equals x minus 1. All right, so it's got a y-intercept of -1. And then if you go through and it's got a slope of +1, so we can go through and say, all right, so that's slope of +1. Well, maybe it should be a little steeper than that. Maybe like that. All right. And so then next we have the right side of the object is defined by x equals 3. So let's just pick a spot over here. Say that's 3. Then we're going to draw a vertical line that goes right through the 3 that I just put. Hold on. Third time's the charm here, right? This is x equals 3. And so, yeah, we'll say that this mark here is 3. Okay, and then the bottom is at y equals 0, and the top is at y equals 2. All right, 2. So the important thing to do is is this 2? Where is the 2? Is the 2 here? Is it here? So sometimes you do need to go through and maybe do a little bit of problem solving to figure out whether the top of the object is where the 2 lines intersect or what, because it could be lower. It doesn't have to be that high. All right, so how could we figure that out, right? So how could we figure out what the y coordinate is there? All right, well, we know the equation for this line, which I, again, forgot to write. It's y equals x minus 1. And we know the equation for this line is x equals 3. And so you can go through and just substitute in to figure out what the intercept would be at this point. So if we just take y equals x minus 1, plug in 3, we get y equals 3 minus 1, y equals 2. Yes, this point there at the top is 2. Okay, and so maybe I should have used a red here. All right, so this is the bottom, left, and right, and then the top we stop at 2. Okay, so let's go ahead and create the new order of integration. So we have f of xy, dy dx. We want y bounds first, x bounds second. So our y bounds go from the bottom of the top, which is at 0, y equals 0. And then the top is at y equals, oh, hey, we already solved for it. Good on us, right? So we got x minus 1. And then the left, right? So where's the left side of the object? The left side of the object is right here. So we don't know what that is. The right side we do know, right? That's given. That's x equals 3. But we need to figure out what this coordinate was. Now there's a couple ways to do it, right? So this line here that's the bottom is y equals 0. So this point is at the intersection of y equals x minus 1 and y equals 0. Or you could go through and use the fact that we have a y-intercept of -1 and a slope of 1, which means we went up 1 over 1. So that is at x equals 1. Okay, and so that's how you go through and change the order of integration. All right, so that concludes the video. Thank you for watching. See you next time.